Oh yeah, much better. Okay. So once you've got all your data in, let's make a scatter plot. Let's just do a second y equals. Looks like mine's ready to go as far as sure. Zoom 9. Well, that's why we just had that up for the past minutes. So there it is. So now again, time on the horizontal. It's a little hard to see, but there's the first data point is right there. Oh, thank you. Thank you, Tony. I meant hard to see because the axis is actually in the way, but thank you for making it clear. So 0, 0 is right here. There's 3.01, I think 25, and then whatever that is, that looks like about 5 seconds, 50, about 6, a little under 6. And you can see what's happening to the data. It sure isn't linear. It doesn't look linear anyway. If it were linear, we'd have more of a constant slope. So what you're seeing with the data is you're seeing this. Now please notice, I'm drawing these, yes? Those vertical runs are the same. Excuse me, the vertical rises. I used the wrong term. The vertical rises are the same at every, it's up by 25 feet each time. So that's 25, that's 25, that's 25, 25, 25. So you can tell it's not linear because the run is shrinking each time. So your rise is staying consistent, your run is shrinking. That doesn't sound like linear data to me. I mean, you'd expect certain noise in data, like the runs won't, and the rises won't be exactly the same in linear data, but they sure won't be like predictably shortening like that. So we decided, I think Tom, you decided first actually, so it's curving, it looks like it's curving. Then we had a bit of a discussion about the different ways you can curve with data. There's more than the ways we talked about. But so we decided to fit a parabola to this data, is what we ended up deciding to do. Fit a parabola, which I think was a great idea, a fantastic idea actually. So let's do it. So it's the same as fitting a straight line. So if you're looking at your booklet, it's the same as fitting a linear regression, except you pick quad reg instead of lin reg. It's the exact thing, except you pick number 5 instead of number 4. And I do want you to appreciate what the hell is going on. Quad reg, make sure you stick the y1 after that. Yeah. Quad reg y1, that way you can actually use the, and you definitely want to have this today because that's going to help us out a lot. A whole lot. It's number 5 versus number 4. 4 is lin reg, 5 is quad reg. Press enter on that bad boy, and you're going to get the equation, and there's the same equation we came up with last time.
What is it?
That was our model that we scratched. If you have the quiz from Monday, we had scratched that model into our quiz, where x is the time in seconds, and y is the distance I have covered in feet. This is the relationship between how long I've been riding and how much distance I've covered. And the real driver of this model is this guy right here. Because if you ignore the ax squared, you've got bx plus c. That's linear, isn't it? That's linear. And there is a linear component, but the overriding, what's actually doing the driving, what's forcing the slope to steepen, is the ax squared part. That's what's forcing the difference away from linear behavior. Yeah. So, if you're looking at that quiz that I handed you, the little hand, that's the model you're going to scratch into the first bit. Y equals 1.58 x squared plus 3.94x plus negative 1.2, or whatever we rounded off to. Well, it is A and B and C, but A and B and C have values. No. A and B and C have values. You're entirely determined by those three constants.
Now, I'm sure you've heard of them. It's
Go ahead.
very informative, but in my mind, remember.
You don't have to. That's the best part. Go ahead.
You said that's so important, the x squared part.
That's what's making the slope curve.
Okay, what
That's
tells you that?
That's the only thing it could be. I'm using, this is a very good question. Kelly asked a very good question. What tells me that the ax squared part is causing the change in the behavior? It's process of elimination. If I ignore the ax squared part, the only thing left is bx plus c, which is a line. If that was driving the ship, we would be seeing a line over time, but we're not. So the only piece left to talk about is the ax squared. That has to be what's driving it. Now, that's a very quick answer to something that you spend 2 weeks on in Math 111 called end behavior. And it's the reason parabolas do this, and as you get further out, they get steeper and steeper. The further x goes out in either direction, in this case that way, the steeper it gets, because x squared is exponentially twice as factorific as x to the first power. So think of the numbers. 1. If you square 1, you get 1. 2, 4, 3, 9, 4, 16. They're getting further and further away from each other, which means this guy's driving the ship more. Does that kind of make sense? Now, great question. It's a great question. I didn't answer it like that in class normally, so thank you for asking it. Yeah, but that's the beauty of quadratic. It's called a leading highest degree term. So that in a polynomial type expression like this, the one with the highest powered exponent drives the ship. And as x goes off to infinity, you can essentially ignore these other pieces and only look at the first one. But we're not going to infinity, we're going to 10 seconds, which is not very far away from 0. But that's why it starts to pull it. Fair enough?
Yes,
Great question. Great. We'll see it again with exponential behavior, but even more exaggerated. Good stuff, good stuff. Good so far? Now, once we have this, you can press graph, and you get your scatter plot plus your model, which looks hella awesome. Quite good, quite good. We have some data that's a little bit, we had some data points that were shifted. Doesn't matter to me. I expect that. I would hope that would happen. It's actually extraordinarily consistent because gravity, I kind of cheated. I knew roughly what it was going to look like because gravity works. I mean, we can just, there, my pen fell. I kind of knew it was going to fall because gravity works. So I knew gravity was going to yank me down that hill at a fairly consistent rate, which there it is right there. When I say rate, I mean acceleration. So now at this point, you can turn your scatter plot off. You can turn your scatter plot off at this point. And the easiest way, I think I mentioned this in the booklet, the easiest way to turn plots off, if you press the y equals button and just unhighlight plot 1, that turns your plot off. So if you're in the y equals screen and just go up to plot 1 and toggle it, it'll turn it off, and you can press graph and just get your curve. You can always go second y equals and turn it off that way. I don't think you did. You just got to do your regression into. So quad ray, perfect. But what we're going to do is we want to do quad ray y1. Now, what I just did right there is this line, and now you'll see it. There she comes.
Oh,
Y1. Here's the button pushes. Ready? Bars, right, enter, enter. I don't expect you to memorize that, which is why, if you look at your lovely guy, page 4, paragraph 1, it's in there. Just keep that handy with you. Keep that handy. It's just a nice little refresher to keep. So that's me. If you think about it, this is a graph where down here, this is my time in seconds, and this is my distance in feet. So if you pick any point on this graph, it gives you a description of when I am and where I am. Does that make sense? When, where. Two different units, time and distance. This is different than grade, because grade was a ratio of 2 of the same units. Feet, miles and miles, millimeters, millimeters. The difference here, amazing yesterday, speaking of grade, coming up Archie Briggs. So I'm a bike commuter, you guys know that. And yesterday was a fine challenge. See if I can ride my bike to work on a skating rink. And the answer is I could do it most of the way. Archie Briggs, out of the question. Now, you saw some of Archie Briggs is ridiculously steep, 17% grade. I knew I wasn't going to ride that. I walked in dirt next to it, which was slippery enough with that sheen of ice that was on it. But there were sections that were tilted no more than, I would say, 3 or 4%. And I had to walk up sideways. Like I was walking on a glacier. I was doing crossover steps like when I climb on glaciers. It was ridiculous yesterday. The coefficient of friction was essentially 0. There was none. If you think about friction, friction is why you can walk. Think about that. Why a bike works, why your car works. The whole reason that you can go forward on a bike or a car, or your feet, is because of friction. When you step, you're pushing back against the earth, and the earth is pushing back against you, and you move forward. Without friction, you're Michael Jackson. Rest in peace. Rest in peace, Peter Buck. That's the whole point, and I felt that yesterday. I pedaled my bike out of my driveway, took a pedal crank, back wheel just spun. I'm like, son of a bitch, this is cool. Because there was almost no friction. So I went back inside and put studded tires on. I have studded tires for my bike, which were slightly better. Margin. This goes back to you guys with studded tires on your cars. I think you know this already. They do not make you able to ride at normal speeds on sheet ice. They make you a little bit stickier. A teeny bit stickier. I saw so many cars yesterday. I stopped one, scared the piss out of me. I got to top of Archie Briggs, got on my bike to ride away, and I saw these eerie yellow and red flashes. I'm like, oh my god, oh my god. I turned around, somebody had come back down Promontory or it slid back into the mailboxes on top of Marbury Butte. And I go up there, I'm like, oh my god, I was watching, I have a VCR in my office and I'm watching movies as I get changed for my commute. Right now Jurassic Park is in there. And the scene in Jurassic Park where the lights are flashing on the Jeep and I'm like, oh, it's a whole so after. And I go up to the car with my headlight shining and the thing's empty. I'm like, oh my god! And I'm like, they probably just walk back home, dude. Relax, there's no dinosaurs on Marbury Butte. But it's incredible to me.
Did you not know?
Oh, it got canceled while I was driving. I was in my house at 5.
Oh.
Yeah, so. We work out up here at 5:30 every Tuesday, but I didn't realize it was going to be that bad, so I just started going. And 2 hours later, I get here, so. Anyway, I didn't come here to tell you that today. Actually, I didn't. It was tied to grade, though. I mentioned grade. I thought of that from yesterday. So, any point on this graph is when I am and where I am. That's the whole point. So, the start of my trip is down here at, I'm going to call this, with your permission, 0, 0. I'm going to call this 0, 0, the start of my trip. I know it's not really 0, 0, is it? It's 0, negative 1.2. If you remember that from last time, if you press the second trace menu value at 0, it's not really 0, 0, it's 0, negative 1.2. Let's just call it 0, 0. We'll force it to be correct as far as the situation goes. Don't worry about that. Don't worry about that. So we're going to treat the beginning of my trip at 0, 0. And I don't care about that anyway, because we don't need to use that very much. What I care about is, where was I when Doc Brown moment. When in the hell was I? When was I at 200 feet? And I believe we said it was 10.1 seconds, yes? Yes. I believe it was 10.1 seconds. There we go. That is 200 enough for my tastes. 200.0 something. So at 10.1 seconds, there we go. I'm at 200 enough feet. 200 enough to call it 200 feet. So my trip, if you're following along on your in-class quiz, the answer to the second question there, what average time did we agree I passed the marker at 200 feet? We're going to call it 10.1 seconds. That was the whole point of that. We're going to need that 10.1 through the discussion for the next, say, 20 minutes of our class. Now, what I want to do next, I want to rehash kind of what we did here. We didn't get much, I didn't think that was about as far as we got on Monday. And we did some other mathematics that I want to redo, because I think the looks I was getting at the end of class on Monday were a little bit confused. I want to make sure we clear those up. But let's take our 5 and wander around, get some air, get some water, and then come back ready to do some good mathematics, some good slopes. And so we don't trip ourselves, let's turn this off. Yeah, get some air, get some water. Let's do some good math. Yeah.
Except for instead of hitting the
Sir, please, yes.